Am I audible? Hello?
Yes.
Yes, sir.
Can you see the screen?
Yes, sir.
Yes, sir.
Okay, so in our last class, we are talking about the fork system call, and uh, we found that using fork, we can a process can create another process, and the process which is creating the process by calling fork is called the parent process, and the new process which is created is called the child process. Okay, so if this is the code, so here this particular process is the parent and it is executing the fork, and we found that fork, it returns a negative value if it is unsuccessful. It returns a value 0 for the newly created process, child process, and it returns a positive value, which is in fact the ID of the child process uh, to the parent or the caller process. Okay, and another point that we found is both the process, the parent and the child, will share the same code segment, or I mean it's not share, but they will have the same contents in their code segments. So if we think of the four segments, the code segment, data segment, heap segment, and stack segment. So if this is the parents segments, code segment, data segment, heap segment, and stack segment. So this, whenever we call for this, parents contents of these segments will be copied to the child's. First of all, separate segments in the child's space will be created, and I mean as a new process it will have its own resource, the segments, and immediately from the parents, the contents of the parents segment will be copied here in a one-to-one basis. And there will be some other say activities also which is required to be executed for a newly created process. We'll see in details what the details of fork is. So this is one of the important step that uh, the system, the operating system, performs when it wants to create a process using fork. And the main point is this code segment, whatever it is written, the object code in the parent gets copied to the child's code segment also. Okay, so in turn we know that the code segment is not getting changed during the execution. So both the parent and the child will have the same content. So the child also will have the same and the parent also will have the same. But whenever the there is a the fork is returned, or whenever there is a return from the fork, by the time this new created process also is there along with the parent, so both will feel that they are returning from the fork, which is called here in this line. The parent uh, will receive probably in this case 24, because the child has been successfully created and its PID is 24, whereas a child will receive a value 0 because it is the child process, and that is how they distinguished, they are getting distinguished. Now using these values, the difference in the values in both the parent and child, we can write suitable codes, and so as to imply that the child and the process, child and the parent process will execute different statements uh, as it is required. So in this case, if it is 0, we write this part, so this will be executed by the only the child, exclusively by the child, and in this case this else part will be executed only by the parent. And uh, we can assume that say this is inaccessible this is inaccessible. Sorry, I think I just, so if this is 0, so this part will be executed by the child, and in this case this part will be executed by the parent. So this remains inaccessible, although it is there, but the child can never execute this portion and the parent can never execute this portion because we wrote it in a if-else statement like this. So in that way, the basic objective of creating a new process or by calling for is to, in most of the cases, we would like to speed up the execution of an application, because the basic idea is if there is a single CPU and if there are multiple processes which are coexisting in the system, because these days we are talking about multiprocessor systems, multi-programming systems. So even if there is a single CPU, multiple processes can coexist, and there is a scheduler software which executes some algorithm to figure out which of these waiting processes will be assigned to the CPU. So if we have got, for a particular application, if we just create one particular say process, then that particular process, I mean, say whenever it goes for input output, taking for input output, then definitely the whole process goes into the block state. So at a time, a process cannot execute the CPU at the same time go for IO. So that is not possible. So in this case, when it requires input output, so the process need to release the CPU. So that is the reason if we write a single process for the entire application, sometimes we lose the flexibility. I mean, we can have a better code through creating multiple processes. We will take the example later on. But
sir,
yes. Yeah, I'm not getting. What is the question?
Sir, in the second code, sir, why would if 0 be that block be inaccessible to a child, sir?
Okay, can you please repeat? Hello?
Sir, my question is that in the second
just a minute. Yes, please repeat your question.
Why is my question, sir?
Your voice is breaking. Okay, can you now ask it once again?
Hello? He was asking why the second code, the upper part will be next.
Why this part is inaccessible to the child?
Yes, sir, that's what he was asking.
Yes. So you see, in the actual code, when the code segment gets copied, so what is written here? It is fork, just fork, right? So when this child got created, so this fork will return something. So if it returns 0, 0 is what? 0 is how 0 is interpreted? True
that's
or false?
False value.
This is false. So if 0 is returned, that means this particular checking, this condition will never be true if it is a child code, right? So if this is always false, so that means this part cannot be executed by the child. Are you getting my point?
Yes, sir.
So it returns 0. So 0 is always interpreted as a false. Anything other than 0 will be treated as true. So this case it is true. We do this. This case is 0. That means it skips here and comes executing this part. Is that okay?
Yes.
So now let us come to the some of the tricky options, and I think maybe one class I should take summarizing the introduction in my own way, because I find that many things I cannot relate, which I should have explained in the introduction. It's a basic introduction. Maybe after this class I'll take one introductory class, although Animesh has taken in his own way, so I can probably relate. So the slides are also ready. Anyway, so let me continue with this class. So if you focus on this, so what is create child.c? So create child.c is this piece of code. Okay, so this code you can see, this is pretty simple code, right? And once we execute this, so there will be two processes created. One is a parent process, one is a child process, and both the processes, after it gets created, they goes into a infinite loop. Can you see in both the cases? So they will coexist in the system with having their own IDs and their parent IDs. So if we execute say ps command, we'll see the presence of both the parent and child, and that will continue forever, right? Now in such a situation, so this is the case. So I compile create child.c, then instead of ./a.out, I -o means I would like to name the object code created after this compilation as create child, right? So that is what it means. Earlier we just wrote gcc's create child.c. That means by default the name of the object code or the executable will be a.out. Now if I write -o, that means I am trying to give a new name to the object executable or the object code, that is create child. Now if I write /create child, that means I am executing that that object that got compiled. And if I write here ampersand, that means what? It will be
running in background,
considered to be a background process, and it will release the terminal, and where we can execute commands, we can do whatever we want. Okay, so once it is forced to be a background process, so immediately its PID is displayed and then the prompt comes. So after just displaying the process ID of the background process, the terminal will be released and the shell prompt will come. And now in that shell prompt, we would like to I have displayed ps-ef, and in that option we can see here that this create child, you see, so there are two processes created using this /create child. One is 275, another is 276, because you have just typed one single command executable by typing the executable name, and one was the parent process. So what is that? So what is the parent process ID? Parent means the original process ID. What is the process ID that got created through this execution, the parent process?
So 275.
Is 275. All others, can you follow? Hello?
Yes, sir.
So once we execute the parent process, we found that there is a if statement. Within if, the parent calls fork. So if it calls fork, automatically the child process corresponding to that parent will be created, and in fact it shows next this one 276, and as you can see, almost in no time both of them has been created. So it is maybe within a millisecond or even a nanosecond it got created. So that's why they are all registered this in the same time, but definitely the child will take some time, I mean after the parent got created. And we can see that the child says that 275 is my parent, so that is indeed true, right? And then after these two processes are created out of this, then I have typed ps-ef. So this process comes next, and it has got a PID 277. So if we look into the process tree, so init, which is a system process that gets created after the booting, then comes a terminal process, that is 6. That's the terminal process. Then comes the bash, the shell process. As you can see that 7 is the child of 6, and then comes the create child, or I mean that actually creates two processes. So the parent process corresponding to that. So the parent process, whose PID is 275, and which is the immediate child of the shell process, and that parent process has executed for, which created this child process 276. So this 275 becomes the parent of this 276, right? Child process. So actually these two processes are created because of this create child. Is that okay?
yes, sir.
Yes, sir.
So now if we call kill 275, What is the purpose of the kill? What we found in some of our last classes?
It's a termination of.
So that will be immediately terminated. So I am just specifically mentioning the PID of 275. So what is that? The parent process. So I would like to, so having this running, and in fact what we found is that both of the parent and the child, they are executing an infinite for loop. So they will remain running forever in the background. Okay, so that will not be terminated until unless you switch off your system, or you explicitly try to terminate it by writing some commands or or by sending some signals, right? So now here, if I write kill 275, that means the parent process gets terminated forcefully. Whenever the parent gets terminated, so the child says that my parent died. So what we discussed, the who will be the parent of the child. So immediately after doing this, after kill 275, if you display PS-EF, can you see any change here?
Yes, sir. Yes. The parent process ID got changed to 1.
So first of all, this parent 275 is not there. It's no longer it's there in the system. So it has been terminated. What is the next case? The next case is the child process still exists. So even if the parent died, the child will remain, will continue. But the only thing changed is earlier the child has got 275 as its parent. Now it has got, what is that? The init process as its parent. So that's why we say that the init1 process becomes a parent of the orphan. So now whoever is not having a biological parent alive, so he will be, so that person will be called as an orphan, right? So in this case also the same thing. So this child will now become an orphan process. This child process will be called as an orphan process. So you can still use the same terminology because it makes sense. And init1 acts as a grandparent of all user processes. It's a grandparent, means whenever the parent dies, it will act as a grandparent. So you can think of an arc leading towards it, right? So this will continue like this. Now consider the case that we are running create child like this, and like you forget about that example. So let us assume that that part is done, and we have, and both the even the child process got killed. We have terminated, right? Now once again run this create ./create as a background process, and immediately the PID of that process gets displayed and the prompt comes, and we try to type the PS command, right? And as it says that there will be two processes created, parent and child. So this part is fine. So just the values got changed. Instead of 2756, if you keep running that, you will get some other number higher than the existing one. So it's 279 and now it is 280. Okay, and the PS command when it was running, it was 282, right? So now instead of so now I write kill 280. So what does it mean?
Terminate the child process.
Terminate the child process.
So we are trying to kill the child process. So earlier, keeping the child alive, we try to kill the parent of the child, and that created the child as an orphan, and init process became the grandchild. Now I say that the child process, we would like to kill the child process. So what do you expect? So the child process definitely will be killed, but after that, if you execute the PS command, can you see the change? Is the child process really gone from that process list?
No, sir.
It still remains, but you have just now killed it, right? So now what it says, can you see this? There's a defined kind of tag that is
defunction
appears. So defunct. So defunct, what is the like English meaning of defunct?
Defunctional.
So it's not non-functional. So it's basically it is there. There is some entry corresponding to that, but it is not functional. So you don't think that it is a active process yet, right? And if you go for a different way of displaying PS. So PS AUX. Then can you see this? So again the defunct is here. It is it's hidden, so it's also defunct. And what is the change here? Can you see the change here? Hello?
Zombie status.
So Z.
So the status becomes so the process status becomes zombie. And earlier for the actual parent, what it was running.
R.
Like in this stage, if you write PS AUX, then that means both this parent and child will be in the running state. Running means they are ready to run, or they are running the CPU and whatever. Now in this case, both is found to be displayed in the PX in the PS command, but one is in the running state, which is actually active and it's probably ready to run, but the other one is in the zombie state. So what is the significance of the, and you see the PS AUX is also in the running state. And what about the rest of it, the bash and all this? They are in the S. S means the suspended state. So suspended means you are so the process is probably doing some input output. That's why it is suspended. Or the process is waiting for some resource to be free, right? So in that waiting stage, that means until unless that the condition for the wait is satisfied, the process cannot continue running or execution, cannot continue its execution. So that's why, so running means either you are some of the statements are executed by the CPU, or it may be that you are completely ready and you are waiting in the queue to for the assignment of the CPU. So these are the two running states, right? I mean, in Linux, basically they both are denoted as R, right? And if you are busy, or if you are waiting for some events, maybe that the process is executed scanf. So scanf means the process is waiting for some keyboard entry, so it will wait for that. Maybe the process is waiting for some signal from some other process, then also it may be in a waiting state. So in the waiting state, it will be denoted as suspended, S. But if a process dies, whereas its parent is alive, then it will be in the zombie state. So zombie, what is the significance? So the significance is again as same as that of the real life situation. So even if a particular say person dies, or maybe somebody dies in the hostel, so you cannot simply wash everything. I mean wipe out everything, every records of that particular student or particular person. So his or her parents may come and inquire that what has happened. We would like to see what has happened, and they may have some they always may have some reasons to know what went wrong, right? So that's why a zombie, the child process PID 280 has died, but the corpse has not yet been reaped. So these are the words that are actually used in the literature also. So the parent process, because it has created the child for some purpose, for first execution or whatever, so it wants that whenever the child immediately got terminated and without reporting to the parent, so it will hold its say some of the entries, or the operating system will still hold some of the entries of that child process which has died or which has been terminated, just for use of the parent process. So if the parent process sometimes think that I would like to inquire about what is the reason, is it a abnormal termination, is it a forceful termination, or is it a normal termination, the parent process is free to do that, right? So it is not only because you have forcefully killed, I mean you have forcefully executed the kill command, even if it is a normal using the exit, a child process terminates, then also it will be zombie. Is that part fine?
Yes, sir.
So we found the use of, so the process has completed execution but still have an entry in the process table. So what is process table? We'll see that all in details with the status as Z. Okay. And
Sir,
what
I had one question. Sir, if when we are killing the process number 279, so process number 279 is also a child of bash, that is process ID 7. So why doesn't 279 becomes
No,
a
it is
zombie process?
so in this case, if you create a process using fork, so yes, that in terms of the hierarchy, it is like that. But if application process creates another application process, only then it happens. Like the system, so that's a part of the system. So the system has created. So this bash has created this. So this parent process is not a part of this bash application or this system application bash. Got the point?
Okay.
So if it is a, so this means that they are doing something, they have got a same purpose. So in the same application, so in the application, this is the small hierarchy where this is a parent, this is a child. So among which, if this dies, this becomes orphan. If this dies, it still remains as zombie. So indeed, it is true that the bash has created, but the bash has created not as a part of it, its own, right? Is that fine?
Yes.
So now one might think that then when and how the parent is will come to know, or I mean, as you mentioned that the parent sometimes may wish to check the status or check what has happened, what went wrong. So in that case, how the parent will inquire such things if it wants. So there is another system called wait, right? So this using this wait system call. So this is there is a significance why it is called as named as wait, but this wait system call, this is one way of reaping the terminated child processes or the zombie processes. Okay, and sometimes in this case, say after the parent has died, the child becomes this init becomes a parent of this child process, right? So now if you after doing so, if you now call kill 276, what do you expect?
So I think there would be no zombie process because it is a separate process. Sir, I think there should be no zombie process because init is a completely different process, like the logic we applied in the previous case for the bash.
See, the point is now whenever some process gets terminated like this, so if it was so if its parent is init, so why it is done? So maybe that after it was, say after it was zombie, it was zombie. Now if I forcefully kill its parent, what is going to happen? The child process has died as zombie. Now I forcefully terminate 279, the parent process. So now it was created as zombie so that its parent can repeat, right? But the parent now has been terminated forcefully. What do you think? What will be the fate of this zombie process? Will it still remain, and for whom it should remain? Got my question? Hello? Hello, am I audible?
Yes, sir.
Yes,
Yes,
sir.
sir.
My question is, after the child got terminated, it becomes defunct, but then afterwards, immediately after that, you kill, say, 279 also. Then what is going to happen? Now, the process for which it was probably some remains were uh, still stored by the operating system, tagging it as a zombie process. So that process, that parent process itself got terminated. So what do you think? Will it remain as something that need to be ripped off later, or what will be the action?
The zombie process also terminates, sir.
Hmm?
So the zombie process also terminates, sir. In that case.
So who is going to do that? So now my question is, who is going to terminate these zombie processes if the parent for which they are stored gets terminated? Who do you think will do this? Is my question clear?
So OS.
The OS, so which process in the OS will do this? সুব্রতা ক্লাসে আছি আমি 4:30 পর কথা বলছি। হ্যাঁ হ্যাঁ so let us see that how it reacts, right? So can you
Sir,
see the
init?
Hello?
Sir, will it be init? Will it be terminated by init?
Yes, that's probably true, right? That should be the case. Now let's see how it works. So we write cat. Okay, so first we write ls. So ls we have got create. So cat create. So this is a code, create child. So this we let us compile. So this okay. So now scrolls up. We have got say create child. You see, this is executable, right? So this is, instead of a out, we have created the executable, and let us run it. So if we run here, so it's running. Can you see this? I've created one more terminal, and there I can see that the create child has created the original parent process along with the child process, and they both are running, right? Because they are going into infinite loop. So I then terminate this, and I find that yes, now both are gone. Now I would like to run it as a background process. So I found that 109 is the PID of that, and if I write here this, so this is indeed 109, the parent, and now 110, the 110 is the child of that, right? And both are running successfully. Now let me first try to kill the parent of it. Okay, so if I kill, so one of the process corresponding to that command /create got terminated, and here we can see, so which one is now retained? So the child process retains, and then if I write here aux, both ways we can see. And what is the change that we found with respect to the previous one? Here 110, 109 was the parent, and now init became the parent. Okay, both ways we can see that this is indeed true. And in fact, AUX never shows the parent ID, so we cannot track it here, but here we can see. And this is running. So 110, the child process is running, right? But this is running as an orphan process. Now, once we know that this one becomes the init process becomes a child of it, of a normal application process, we say that that is an orphan process. Okay. Now, if I now let me kill this also, kill 110. So kill 110, and if I write here PS AUX, now there is no trace here, right? So the child who was parented by the init process now completely goes off. There is no trace of it. Why there is no trace? Why in this case the zombie state is not created?
So because init process is separate as a separate process, not associated with.
Yes, actually the thing is init process is, so it is just trying to go for a for caretaking, right? So it is not the original creator of the child process. So it's just a caretaker kind of thing, and somehow we are trying to identify it as a parent, because in the process data structure, in many other cases, identifying the PID is extremely important. I'm sorry, PPID, the parent process ID. So just to make it say similar, the parent ID field is not null, and this also the case. And in fact, init process, it has got other responsibilities also. If it finds that some process, so that some process is becoming zombie, so if it is directly under the init process, immediately can clear it out. Or the OS knows that okay, it is already under my control, so its original parent has already died. So if that process gets terminated, so there is no point of storing its remains anymore. Are you getting the point? So some process created by some other application process, which is going to be the parent. Now, if I know that the parent died already, now the init becomes the parent of this child process. Now, if this process dies, so there is no hope on. I mean, it can never be true that its original parent will come and ask that what has happened, because the parent already died. So because of that, the OS will not create unnecessary zombie state for that particular process, or it will try to store the remains of that. Is that part fine?
Yes, sir.
Now, if we again, so now there is no more application processes. Now, if we do this, and we find that now again a parent and the child got created. Now, if I try to kill, the child process instead of the parent, now you see the defunct appears. Can you see this? And it is tagged as Z. Okay. And who is its parent? Parent of that, it is 115. That is still true, but it is non-functional. Okay. And because it is non-functional, now if I kill its parent, original parent, what do you expect? Now there is no trace of this defunct also. So if a process is terminated, we'll see later on that as like the creation, what takes place when a process gets created, what are the actual steps that are which are executed. So same in case of when a process gets terminated. When a process gets terminated also, there are certain steps that is followed. So we'll see that what exactly it is, and then it will be clear. But for the time being, you should know that if the parent of a defunct process is terminated forcefully, then the operating system will definitely remove the corresponding defunct child of that process. I mean, that is the termination itself will take care of that. Okay. So how it is done and what are the exact steps, we'll see later on. And corresponding to fork creates a new child. The just the reverse of fork, or it's just similar to fork. We have the exit system called EXIT. Exit will terminate a process. So it will do just the reverse activities that has been carried on during creation, right? So we'll look into the details of both exit and fork later on, the system. Okay, so now there is another Any question till now?
No.
So now can you see the screen? This one.
Yes, sir.
So init balance. So let us focus on this code, init balance. So it is care. What is written in the code? It's a pretty simple code. Can you see the code and tell me what is the purpose?
So it parses the balance from the file and displays it.
First of all, it opens a file account balance.txt. It's a text file. And any text file, if we open it in the editor, we can see the contents. We can read the contents. But if it is an executable file, or if it is a say binary file, then it will be the characters will be stored in binary in its binary representation. So it will not be easy to read or decode in the editor, right? So if it is a text file, generally we prefer to give the extensions .txt, so account balance.text, and we have opened it. I think by the time all of you have executed some codes for opening a file, for closing a file, for manipulating a file, I think that part is done for text files. So if I write fopen, so it has got two arguments. One is the name of the file that you need to open, and hopefully that is in the current present working directory. If it is not, you have to specify the complete path of this particular file, right? And then after comma, we have got another string that is specifying the mode of that file in which it will open. So it is W plus, it's in the write plus mode. Okay, and then it is fprintf. Fprintf means, because it's a text file, if you would like to say save or store something in that file, we call this fprintf. So printf, we know whatever format we specify here, it will be printed. So just focus on this part. So balance colon and then the value that we want to type, it will be displayed there. But if I write here fprintf, that means file printf. So write it in a file, and this f1 is the it's a identifier. It's a this file pointer f1. So if I specify that, so these things will be stored in that file, and then we close the file, specifying the file pointer. So if I run this piece of code,
so what is the difference between W and W plus? Like,
so you'll also go. It will. So one is the append mode is there. So you can append or you can write. Both are possible.
So write means it will start from the beginning, and append means like
Append
wherever
means,
the last line was
see,
after that.
now see, if you W plus means you can read on read also, you can write also, and if you only write it, so its contents will be removed completely. But once you open it in the W plus mode, you can read it and you can write it also. You can write it also and you can read from it also.
Okay.
If I write here neat balance, okay, let it be neat balance. Neat balance. So if I write so what do we expect once I execute this? We expect a file to be created, account balance.txt, right? So if you open a particular file in the write mode, if the file is not there already existing, so a new file will be created in that name, and whatever you write will be saved there, right? If you close it properly, you have to open and you have to close the file, and in between you can read, write, whatever you can do, you can do. Now if a file is already there existing, then if you open it in a write mode, it will be, so all its contents will be removed, and afresh items will be written in that file. Okay, so in this case, once you have done that, so what we expect, ls, if I write here account balance. See, that file has been created, right? So if I write here ls and you see it is just now created, this file right now, 1 minute back. So now if I cat, I find. So can you see the balance? It shows the balance 2000. So it's a text file. So if I type the text file, it will display. So it will display the contents, right? So there is no problem here, right? So now if I for a execution of this executable as a background process. So as a background process, it gets okay. Now let us try it for this application. So this is fine. Now we have this balance update. So balance update, what is balance update? Now cat balance update.c. Can you see the contents of it? What is the purpose? What this code does?
Incrementing it to 200.
Can everybody see the screen and decode what is written?
Yes, sir. It takes the current value from a balance and increments it, and again print it. The file.
A file that opens the account balance.txt in what mode?
The read
mode. If it is in a read mode, that means what? If this file already exists or already exists in the system, it will retain that value. It will not remove that value. So read means whatever it is there, it will just open it for reading purpose. So if I now you see when I am writing something in that text file, I was typing fprintf. So when I will be reading from it, it will be fscanf. It is the file version of the scanf, file read version of the scanf. So fscanf. Now the way we scan, we go for scanf. It is the fscanf. It is all the same. Only this file pointer f1, which is identifying that file, f1 will be just mentioned here. Okay, and then the same way this contents of this x will be read from that file itself. So what value this x will get if I read in the same format? So I have given the format balance colon and then integer value. So if I specify that format, it will just read from that file following that format. So what value this x will get now?
2000. 2000.
So whatever it is written in account balance.
So right now I just found that it is 2000, right? So 2000 will be read from it.
Yes, sir.
And then it will close the file, and then it will increment 2000 plus plus. So it will be 2001. Okay. So if it is 2000 plus 1, so if it's 2000 plus 1, then it writes the update balance to the text file. So now after it has done that, so you see it read, and after it read, it just close the file, and it will do the updation, and then after the updation, it will again open the file in the write mode. You see W plus in the write mode, it will open the file, and it has opened the file, and then it will print whatever it has been updated, and it will again close it. Okay, so it will. So it will not only, it will first read, it will open, read and close, update, again it will open, then write and then close. That's what it will do. So for reading, it will open it in the read mode. For writing, it will open it in the write mode. So whatever contents was there, if it is opening in the write mode, it will be just overwritten. It will be just ignored, and the new value that it has updated will be stored there. Are you getting my point?
Yes.
So now if I, what is the file name? Okay, balance update, yes. So now if I write GCC balance update, so what will happen? What do you think if I, so once I execute this balance update once, what value do you expect to be in the account balance?
2200.
2200.
Okay, so sorry. 1200. Fine. Again, if we run, it will be
2400.
2400.
okay. So now we know that it is doing things perfectly okay. Every time it increments, it is doing that, because you see it says that you have to increment 200 times. Now if I do it like this, say I reset it to 2000. So how to do that? I reset it to 2000. I just write init balance.
Hello.
Hello.
Sir, when we are writing into the file, we are writing in the appending mode.
We are writing in the
Appending mode.
no. If I open it in the if I open it in the write mode, so whatever it was there, it will be completely ignored. So it will be simply washed out, and then whatever you are writing, it will write it afresh.
But sir, it's W plus. So
So it
W
will
plus
not
is
be. So it is not in the append mode. In the append mode, if you do an append mode, so 2000, then next comes 2200, then next comes 2400, like that. So it is not in the append mode. In the write mode means it will simply overwrite that. So the previous contents will be simply it will be erased, and whatever you want to write will be written.
So is there a mode where we can specify that we
Mm-hmm.
want to write it in append? So is there a mode? Is there an option?
Yes, append mode is there. A is there. A.
Oh, okay.
There is append mode specific. There is a specific code for that. We are not interested in appending right now. So we have got some different things to discuss. Yes, you can always do it. So W, R, and A. A is for append mode. So can you see? So what is the current value of this account balance? It is 200, right? So now my intention is to run this balance update, but in the back as a background process. Okay. Now do it. Again I do it. Again I do it. So how many times how many processes I done this balance update?
So 3.
3 times. So if I would like to display the contents, what do I expect?
So 2600.
What value it is? What value it is showing?
2596.
So let me try it once again. Init balance. If I do it, then its initial balance will be 2000, right? Now I run this update balance. Now how much do you expect? What will be the value? What value do you expect?
3200. 3200.
And what value it is giving?
2686.
There's a huge gap, huge difference, right? Why it is happening so?
So because the value is that file is shared between the processes. And
Can you see the problem, the anomaly? Is it felt? Hello?
yes.
Now if I again do it, you see, I do it, and then so definitely its value will be this. Balance update. balance update, and then I can. Now this time it is 2400. So what is happening?
In between files are running.
So now it is correct. So sometimes it is correct, sometimes it is not correct. So what is the problem?
Two files are running, although one is not executed properly.
No, all are executed because you see both are getting completed. So individually the processes are executing perfectly fine, but when it comes in the file overwriting and all this, so the values that we see is not correct. What is the problem
Sir,
then?
is it because the second process is starting before the finish of the first process?
That is fine. So there lies the problem, but why the problem occurs?
So because updates, so let's say the current value of x is 4 and we have incremented it to 5, but before incrementing the other process is also getting 4. So that that incrementation statement thinks that the value of x is 4 instead of 5.
Any better answer?
Sir, due to
Because
switch cases, context switching, this is happening, sir.
Yes, sir.
Context switching. What is context switching?
So the data is being read by the second process before it gets overwritten by the first.
Say this is the file, right? So where a file is stored?
It's a hard disk.
A file is stored. Oh, phone. হ্যাঁ অনির্বাণ আমি ক্লাসে আছি ওই 4:45 কটায় ক্লাস আছে 4:45 বেজে গেছে হ্যাঁ আমি এই ক্লাসটা শেষ করে শুরু করবো এই 5 মিনিটে শেষ করবো হ্যাঁ হ্যাঁ ঠিক আছে See the files are actually stored in the hard disk, right? So it is there. So something is stored 2000. Now you have got two processes. One is this. Say this is say the first instance of that create child or whatever. So this is process P1, this is process P2, this is process P3 like this. Now, so whenever you have got, you see, so this file is opened. So corresponding to that file in the operating system, it maintains a file table. Okay, and if you have opened this file, so there is some entry. So the entire file is not copied in the RAM. Rather, in the RAM, as a part of the file data structure. So the details we'll see later on. But you can think of there is a file table, and corresponding to each file there is a corresponding entry of that file table, right? So if this is a balance.txt. So corresponding to balance.txt there is an entry here, and so if this process has opened, so it will get some control over it. If this process opened, some control over it, and like this, right? So what happens? So if this process it reads the value, so through this it basically reads this value, and say maybe it stores 2000. It increments, and once it reads, it closes it, right? It closes it. After it closes it, it increments it to 2001, right? So it is about to write 2001. This plus means. But before he again opens it in the write mode, maybe the P2 reads it. Are you getting my point? Hello?
Yes, sir.
Because both P1, P2, P3, all these three are ready probably. They all are eager to open the file and do some changes and then write it back, right? Read, update, read and close, update, open, write and close, right there. So now P1 does it. Now P1, when it does the file operation, so whenever it is going for the file operation, it was to release the CPU because it's a kind of external IO, input output kind of thing. Releases, but whenever it goes for releasing the CPU, might be the process P2 gets hold of the CPU, something like this. So this goes on, and in this case what happens, like P1, it has read from the file 2000, it has updated it. Now it is waiting for the file to be to again open that file. Meanwhile P2 was scheduled, P2 opened the file and it also read what? So you see, so P1 read 2000 and before it could modify and again write it back, because when it was updating X++, so it may be that the scheduler has scheduled P2. That is possible, right? P1, P2, P3 are all the same. So maybe because of some reasons, the P1 has been taken out from the CPU and P2 got scheduled. And P2, what it read now? It will again read 2000 only, right? Is that clear?
Yes.
So it also reads 2000. And now this also increments and it becomes 2001. And meanwhile, maybe P3 or maybe, okay, forget about P3. Now, before P3 gets its turn, maybe P1 again got scheduled by the scheduler. We don't know. Now, what the P1 is going to write here? What the P1 is going to write here? This value, right? So what it will write? 2001. Is that okay?
Yes.
Now, before P2 gets to write on it, which has incremented, which is waiting to write 2001, P3 got its turn. And what P3 will read? It will increment to make it 2002. Now what happens? Even before P2 gets its turn, it might happen. We really don't know how the scheduling is done and all this. It might happen that P3 got a chance to write it back also. So P3 will write here 2002. And then after that P2 got its turn, we'll see that there are many policies and which might make the P2 wait before it gets a turn, even before P3. So now when P2 gets its turn, it will write what? What value it will write? P001. So both of all the three processes has read, updated, and they are about to write. And after they have committed all their writes, all the three processes has done. So instead of showing here 2003, what value it's shown here?
001.
1. And if it happens that before P3 writes, P2 also got its turn to write it back. So what it would have written? 2001. And in that case, P3 would have written its updated value, say, as the last process. So what it would have updated then? It will be 2002. So now, so the outcome of this operation of this execution of this code, like, can you predict the outcome? That will it be 2001 or 2002 or 2003? Can we say for certainty what will happen?
No, sir. Depends on how the process.
So wherever this outcome of a certain operation is unpredictable, or you cannot determine this, we call it as, what is the term that we use? That condition. Heard about this term? Have you heard about this term, race condition? Hello?
Yes. Yes, sir.
So this is called race condition, because race condition means you don't know the outcome. What will be the outcome, you don't know. So that is a race condition. Okay. So this was the case. A race condition is a situation where the outcome of some operations is unpredictable, and in this case, that is what is happening. Okay.
Sir.
Sir,
but why should this ambiguity arise? As because the all three processes are not created at the same time. So why this?
If I delay it a little bit, then by the time 200 times reading, updating, and writing, this goes on. So that's, if I delay it a little bit, slightly later, if I create this background process, wait for a while, take a long breath, and then I create the second one, then wait for a while, nothing will happen, because by the time the process 2 gets created, process 1 gets completed. You see, there is a small bit of delay that it takes. It's not all of a sudden. So it takes maybe 1 second. So within this 1 second, if you somehow manage to create another process, you are inviting problems. And even before the second process gets complete, if you manage to create the third process, so you have created a series of problems for you. But if you do it a bit lazily, so one will be over, then the next comes, and next, and nothing will happen. And that's why we found that in the last stage, in the last execution, I did it a bit slowly, and it was actually 2400.
Sir, could you please explain that part once again? That file dot balance dot txt is somehow represented in RAM. Like how is the address stored in RAM? Like so
No,
that.
this part I'll not do it right now because it will complicate the whole thing. It is there in the discussion. In the next, I think next to next class it will be done. So right now you understand that instead of copying the entire file in the RAM, there is some entry that is some table that is maintained called file table. That's a global file table in the system, and the global file table will just have an entry corresponding to the file, any file that you open. And if the file is shared by multiple processes, they will all have a tag to that. So file pointer, file pointer. So file pointer. So these are basically a structure is created for that particular file that has been opened by the system, some process in the system.
Okay.
So if you write file asterisk f1, so that f1 is actually pointing to the address of that structure. So each of them, whatever the variables they have got f1, 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 but they have got in their own copy. So each of the f1s will be pointing to this, and through this record itself, each process will be able to manipulate that file. They will be able to jump to that hard disk and find out what to be read and what to be written.
Okay.
Sir,
okay?
can't we say the reason for this race condition is context switching?
This is, yes, it's definitely it is context switching, but I have not yet talked about context switching. The problem is the coexistence of multiple files in the system, and because they are sharing a resource, it might invite problems. So whenever you have got point or things that you would like to summarize. So whenever you have got multiple processes sharing some resource whose state will be modified, might be, then you need to be very cautious, because at the end the outcome may not be predictable because of race condition, and there will be inconsistency, there will be unpredictable values. So this is something very common in our operating system, and that to deal with that, there are some topics that we read here. It is process synchronization problems. So process synchronization primitives. So whenever processes try to coordinate and they try to share some resource, we need to use process synchronization primitives like semaphores or monitors or all this to take care of this problem and make sure that such things never occur. Even if they all use a particular resource simultaneously, these situations will not occur, that it will end up with a unpredictable value. It will be consistent, that can be guaranteed. Okay. Hello.
Yes, sir.
So I've got a meeting from 4:45. I need to leave. So any other question you can ask, otherwise I'll be answering it in the next class.
Thank you, sir.
Okay.
Thank you, sir.
Thank you, sir.
And sir, will you be uploading the slides?
Thank you, sir.
Yes, I'll upload the slides. I think the previous slides I've already uploaded.
Yes, sir.
I think in that previous slides itself, you will have these slides. These are all there. Otherwise, I'll upload it.
Okay, sir.